So we're going to graph all 6 trig functions by the end of, probably this next week. So secant and cosecant. So cosecant, we know, is the reciprocal of sine. So you can kind of think about it as 1 over sine of theta. So what I'm going to do is I'm going to kind of sketch the sine graph for this. So remember that sine starts in the middle and then goes high, middle, low, and then back to the middle. However, I'm not going to actually graph it. And some of you don't have to do this, but it's kind of helpful, is I'm actually going to dash in the sine graph. Okay, so there's my sine graph. Well, if sine is 0, we have 1 over 0. Well, 1 over 0 is undefined, and we graph undefined with asymptotes. So my graph is going to end up having these asymptotes, these vertical invisible lines that we draw using dash lines to denote that it will never cross the vertical asymptote. So then, what does the actual cosecant graph look like? Well, let's just think about 1/2. What's the reciprocal of 1/2? Well, 2. Well, every kind of reciprocal of this fraction ends up just becoming bigger and bigger. All these little numbers that are getting closer and closer to 0 are actually going to infinity. The same thing happens over here. So the graph ends up going in that direction. Down here, if you do the reciprocal of -1/2, you get -2. So your graph ends up going like this. So this is what the cosecant graph looks like. We have 3 asymptotes. Those asymptotes are where it crosses the middle, the sinusoidal axis, that axis of oscillation. That's where your asymptotes are. So when we start moving them up and down, your asymptotes will be where it crosses the middle. And then the actual pieces of the graph of the cosecant is this. Some of you, if you don't like to have this dashed sine graph in the middle, you don't have to. So what about secant? Well, secant is a reciprocal of cosine. So what we're going to do is we're going to dash in the cosine graph. And you can kind of see that I kind of did a little bit of prep work. So you can do VAPI on this. My vertical shift is up 4. So 1, 2, 3, 4. So this is where my middle is. And again, if you're the type of person that doesn't want to draw the middle, you don't have to. But it's going to be helpful to see where your middle is, just, for the sake of graphing. So that's at 4. My amplitude is 3. So I'm going to go up 3 to 7 and down 3 to 1. Well, my phase shift is to the right 70 degrees. So I'm going to start here at 70 degrees. Well, my period length needs to be divided by 2. So we get 180. Well, that means from the beginning to the end, it's going to be 180 degrees. But what are my quarter points? Well, you take that divided by 4, and you end up getting 45. So we're going to go in intervals of 45 degrees. So we end up getting 115, 160, 205, and 250. So if I'm going to graph or dash in my cosine graph, I'm starting here at 70, and always cosine starts high. If it's being reflected, then it starts low. Then it goes to the middle, then it goes low, and then back to the middle, and then high. I've seen people where they kind of put a dash line for the maximum and minimum just to make sure that your graph sticks between those. Putting those numbers there are kind of helpful. Again, making sure that you're not going all the way down to 0 because the lowest point is actually at 1. So again, if you would like to, you can dash in the cosine graph. And then what we want is we want 3 asymptotes. Well, if I cross the middle here, I have an asymptote at 115. I have an asymptote here at 205. Well, where's my other asymptote? What I'm going to do is I'm going to extend the graph a little bit more to the right and say that it ends at 295 so I can hit the middle again. You can actually go in the left direction if you want to. I went to the right and got an asymptote here. Because the way that we like to graph it in PreCal is to have 3 asymptotes and 2 kind of full of these kind of parabola looking things. So we want to see this and we want to see that. If you want to, you can add this kind of piece over here. to say that it kind of keeps going, because that's what happens with sine and cosine. It just keeps on going and going and going. So we want to just be able to see that. So that's what the secant graph looks like. For cosecant, I didn't have to extend it. For secant, you do, because we want to see 3 asymptotes and 2 of these kind of parabola-looking things. Okay. So let's talk about now, if I give you a graph, what the equation looks like. So I had some room at the bottom, and I wrote this out. So I'm going to pause the video here so you can write this down. So what I have here is y equals something blank. This is where your trig function is. It's going to change depending on where you start your graph. So this could be sine, it could be cosine. We're going to talk about graph or writing equations for secant, cosecant, tangent, and cotangent. So this blank here is for your trig function. We have b that's on in the inside of it, theta, because we're in degrees, minus c plus d. So a formula that I like to use when I'm writing equations of this, and you could think about it just as transformations and write the numbers out. Or for those of y'all that like formulas, A, my amplitude is always going to be the maximum value minus the minimum value divided by 2. Our value of B is 360 divided by how long we give you for the graph. C is where my graph starts. And then D is always going to be the middle. It's that vertical shift up and down. So to find the middle of my graph, I just find the average. So max plus min divided by 2. So if you at least remember one thing, is average. To find the middle of something, you're finding the average. Add them and divide by 2. A is the opposite operation of that. Okay, so let's do some work here. So I'm going to zoom in a little bit. All right, and autofocus. All right, so for A here, for this problem, I'm going to do the maximum value, which you can see is 100, minus the minimum value, which you can see is 10. Now I'm going to divide that by 2. So my amplitude is 45. It's not 45 degrees. These are all just numbers, so make sure you're paying attention to what units you're using. B, in order to figure that out, I take my original period length for sine or cosine is 360, and I'm going to divide it by the period length. So figure out which point you want. I'm going to look at this point here at 12. I'm going to go from 12 until it repeats itself again at 42. So again, this is going to be one cosine graph from here to here. So if we start at 12 and go to 42, well, that's a difference of 30 degrees. So you end up getting that B is 12. If we told you B is 12, you would do 360 divided by 12 and find out that your period length was 30, and then divided by 4 for increments and quarter points. C changes depending on where you're starting. If I wanted to start my graph here, I would start graphing a negative cosine graph. If I wanted to start here, this would be a positive cosine graph. I'll put a theta there. Okay. Because here we're starting low and going all the way through. Up here, we're doing the max. So we start here and we go through that way. Well, I'm just going to start at 12 because I want to. You could start again at 24 and you're going to have, or actually not 24, 27, because that's where halfway between those are. So just choose whichever one you want to, unless we specify. And here we're definitely asking for a cosine graph. So we want to start here or there. Finding our value of D is finding the middle. In order to find the middle, we find its average. So we take the maximum plus the minimum and divide it by 2 and get 55. So notice that C is the only thing that's in degrees. So my equation would be y equals, it is an equation, it should be y equals our A value 45, and we're starting down here, so it's going to be a negative 45 cosine B theta minus C plus D. And some people like to put that 55 in the front because they do vertical shift first. It doesn't matter wherever you put it. It just, for me, I always like to think about it as A, B, C, D. It's in that specific order. So again, if you wanted to, you could have done the other equation where everything pretty much is the exact same, but it's going to be a positive cosine if you start off at 27 degrees. So really, there's a whole lot of equations you can write here depending on where you started. If you start here at 42, it's going to go back to negative. So just understand that there are going to be different equations, but depending on where you start is what your answer will look like.
So in this next problem, we are looking to write an equation in terms of sine. So sine graphs start in the middle. So we kind of have to do some kind of work here to figure out where the middle is, which is our value of d. So let's find out what d is first. So the value of d is the maximum plus the minimum divided by 2, the average. So the maximum is 2, the minimum is negative 8, and if we divide that by 2, we end up getting negative 3. So that means the middle of my graph is somewhere here. So the point where I'm looking for is going to either start here, which they don't tell us an x value or a degree value for that, or here, which we can kind of guess what happens there, or here. So we can start at any one of those points. But we kind of need to do some problem solving before we do that. It is safe to assume that here we start at 10. So at 10 degrees, our maximum value is at 2. Then at 40 degrees, we're there. So at negative 8. So that means that from this maximum point to that minimum point is 30 degrees. Well, that means from the maximum point to this middle point here is 15 degrees. So that means we're going 15 degrees all the way through every kind of quarter point. So we end up getting that this value here is going to be at negative 5 degrees, which I'm going to use as my C value. Well, then B, we we could kind of realize like, well, what is our quarter points, or what is our half cycle points, or we could think about our full cycle points. So if half of a cycle is 30 degrees, then that means a full cycle is 60 degrees. So then if I do 360 divided by 6, or 180 divided by 30, and we end up getting 6 as our value of B. So our full period length is 60 degrees, a half cycle is 30 degrees. So either way you think about it, you end up getting the same thing. And then our amplitude is going to be the difference between our maximum and minimum value, or the distance from negative 3 up and negative 3 down. So you end up getting 5. Alright, so now that I have all of those values, I can now write an equation. And depending on where I start, depends on which trig function I have. So if I'm going to start here at negative 5 degrees, that's going to be a positive sine graph because it goes middle, high, middle, low, and then back to the middle. If you start over here at 25 degrees, you're going to end up having a negative sine graph because we're going middle, low, middle, high. If we start over here at 55, that's sine, positive sine because middle, high, middle, low. Please pay attention to directions. I'm not starting at 10 or 40 because those will result in cosine graphs. So I'm going to do y equals the a, the amplitude, 5, and then we're doing positive sine because we're starting at negative 5 degrees. Our b value is 6, and it's theta minus c, so it's going to be minus negative 5 or plus 5 degrees, and then plus negative 3 or minus 3. Again, pay attention to directions. Sometimes we even restrict you to what value of c to start at, so that we don't have all different types of equations. We could just have one.
And what about half cycles and quarter cycles? Well, what I would like to think about these as is, instead of dealing with a whole cycle length of 360, we're going to do 180. So let's kind of do the same thing, where if I have our value of A, it's the maximum value, which is up here at 4, minus the minimum value, which is down here at negative 3. So max minus the min divided by 2 is 7/2. Now, I want you to be very careful with decimals. If you put 3.5 and I can't really see your point, then it looks like 35. So can you misread 7/2? No. So just leave it as a fraction. What about B? Well, again, we're dealing with a half of a cycle. A full cycle of a graph is 360. So let's change this to 180, which helps us out because if we're starting here and going there, that's 1/2 cycle from 400 to 600 is 200 degrees. So we end up getting 9/10. So there's no instructions here on where to start. I'm just going to start here at 400 degrees because it's easier. I don't have to do any other work. I don't have to do any other thinking. If you want to start at 600, because again, that's another no-brainer there. That's where it gets to its highest point. Down here, negative cosine. Up here, positive cosine. Then our value of d is finding the middle. And again, you find the average. So you take the max plus the minimum and divide it by 2. And you end up getting 1/2. Okay, so again, a lot of formulas, a lot of just deductive reasoning, looking at a graph and seeing what information you have. So if I start here at 400 degrees, it's going to be a negative cosine graph with an amplitude of 7/2. My b value is 9/10. Theta minus 400 degrees plus 1/2. That would be my equation. And again, if you change the starting point at 600, then it's a positive cosine graph. So you don't have to write 2 equations every time for the notes. Just wanted to make sure you understood, depending on where you start, changes the graph. All right, what about quarter cycles? Well, quarter cycles, you kind of need to figure out where the graph is. Is this point here a maximum or minimum point? Well, this is actually a minimum point. My graph is going to go back up in this direction, and this point here is actually on my middle. So the middle of my kind of sinusoidal function is here at this point. So that means our value of d is pretty easy to find. That was at -60. So again, this is a quarter cycle. This graph, this point here is a minimum, and it's going to go back up and just keep on, repeating. This point here is a middle. So your quarter cycle is going to be different from picture to picture. So just understand what is actually given. You can kind of see a curve here, so you know that it's going to curve back. Okay. So our amplitude is also something easy to find because amplitude is always the distance from the middle to its highest or lowest point. Well, from -100 to -60 is 40. So our value of b, well, since we're talking about a quarter cycle, a full cycle is 360, so a quarter cycle is 90. So if I want to divide that quarter cycle by how long it is from 24 to 36 is 12 degrees. So you end up getting a fraction of 15/2. And again, if you want to put 7.5, that's fine, but make sure that your decimal point is very visible. So we're not given any instructions on what to start at. So I'm just going to start here at the point that they gave us at 24. So my graph ends up being y equals my amplitude, and it's going to be negative since I'm starting low, cosine of b theta minus 24 degrees minus 60. So again, your c value is the only thing that's in degrees because that's the only axis that's in degrees. Our b value, it's dividing 2 degrees, so they cancel off. So really practice this. You do have a quiz on Monday over this, just knowing information about sine, cosine, secant, and cosecant. If you have any questions, make sure to ask before the quiz on Monday. Thanks. All right, so remember when I told you that we're going to graph them all? Well, here's the last 2. So we're going to be graphing tangent and cotangent today. So what we're going to do is we're going to kind of go back to those quadrantals that we talked about. So remember that when we have 0 degrees, we have the point 1, 0. At 90, we have 0, 1. 180, it's -1, 0. And then down here at 270, it's -0, -1. So in order to graph tangent, it's going to be good to kind of have this information. So if we're talking about at 0 degrees, that's here. Tangent is at y over x. So if I divide 0 by 1, I get 0. So sweet, I get this point 0. And you can kind of see I did a little bit of pre-work before starting the video. So what about up here at 90 degrees? Well, y divided by x would be 1 over 0, so it would be undefined. So what I'm going to use is this tick mark right here, and I'm going to say that that's 90 degrees. And it's undefined, so I'm going to do a vertical asymptote. Well, how else could I, figure out some more points here? What's right between 0 and 90? Well, 45 degrees. Well, 45 degrees has the point root 2 over 2, root 2 over 2. So tangent of 45 degrees will always be 1. So here at 45 degrees, it's 1. So I end up having a piece of the graph that looks something like this. Well, I could figure out what's going to happen to the right of 90, but let's actually go back over here to the left of 0. What if I go negative 45 degrees? So in this case, it's negative 45 degrees. Well, again, both the x and the y are exactly the same, except that the y value down here is negative. So if I divide a negative by a positive, I end up getting a negative 1. So at negative 45 degrees, I get negative 1. And what happens if I go down here to negative 90? Well, y divided by x, negative 1 divided by 0 would be undefined. So I end up having a vertical asymptote here, and the rest of my graph kind of goes in this fashion. So this kind of looks familiar. It looks like the cubic function, but the cubic function just keeps on shooting off from the right end to end up, and the same thing left and down. It just keeps on getting bigger, both x and y. With tangent, it's stuck between these asymptotes. And this gets repeated every time. So it just keeps on repeating itself, just the same graph over and over and over again. Now notice something about this parent function. So it looks like the cubic function, we start and end with asymptotes. However, one period length went from negative 90 to 90. So one period length, one cycle of the tangent graph just repeating once is only 180 degrees. So that changes our regular period length that we used to have for sine and cosine. Something else that's going to be helpful to know is that every graph that we've been moving from, x squared all the way to secant and cosecant, we've been moving the origin. So look at where the origin of tangent is. So this is the point that we're going to be moving. And I'm going to do a couple practice problems with you just to kind of help you know how to shift that. So what about cotangent? Well, cotangent at 0 degrees is x over y. So 1 divided by 0 would be undefined. So that means I would have an asymptote here at 0 degrees. If I went 45 degrees, well, again, cotangent is x over y. So at 45 degrees, it's both the exact same x and y. So we start off here at positive 1. If I go up to 90 degrees, I have 0 comma 1, which x over y would be 0. So I have a point here at 0. Then at 135, if I keep going in this direction, I would end up getting negative 1. And then over here at 180 degrees, well, y over or x over y, negative 1 over 0, undefined. So I have an asymptote at 180 degrees. So my graph for cotangent looks something like this. Whoa, and I missed that point, so I'm just going to make it bigger. And that's okay for you to do. If you miss the point when graphing it, just make the point bigger. So that's what the cotangent graph looks like, and it keeps on going towards that asymptote and this asymptote. Look at that. They almost look like reflections of each other, but look at where cotangent starts. Cotangent starts at this vertical axis at 0. It starts off at 0. So we're always going to move this point. So for tangent, we move the middle. And for cotangent over here, we move the first asymptote. I'll just abbreviate it. Okay. So make sure you're doing that. And I'm looking down at our notes and noticing that there aren't really any moving left and right of tangent. So I'm going to probably change one of those. Yeah. All right. So let's look at number 3. So you could do VAPI for this, but VAPI has A for amplitude, and amplitude always goes from the middle to its highest or lowest point. Tangent doesn't have a highest or lowest point, doesn't have a maximum or minimum because they keep on going forever. So 2 tangent of 3 theta. So this 2 in front, you can think that it stretches it vertically. So we're going to move our graph from high 1 to high 2 here. And we're going to do the same thing here with -1 and -2. So we're stretching it vertically by 2. So this point that I used to have at 1 is now 2. And you can see that I changed my scale a little bit. What about my period length? Well, for period length for sine, cosine, secant, and cosecant, it's 360. But for tangent, you have to be very careful. The regular period length of tangent is 180 degrees. So I'm going to divide that by the b value here, which is 3, and we end up getting 60 degrees. So that means from the beginning and end of my graph, it's going to be a length of 60 degrees. Well, if you divide that by 4, well, we end up getting 15 degrees. So I'm not moving this center point at all. However, it is good to know that that point stays there since we're not moving it left or right. So my origin point stays here. Well, if I'm going in increments of 15 degrees, then this is 15 and this is 30. So notice that I don't put 4 tick marks to the right. Tangent's a different graph. Since the middle is here, I go 2 to the right and 2 to the left. So wherever you move it, up, down, left, and right, your tick marks are always going to go 2 left and 2 right. So the farthest left one will always be an asymptote for tangent. The farthest right one will also be an asymptote for tangent. Well, tangent looks like that cubic function. Since we're not reflecting it, this 15 degrees ends up being at 2. This negative 15 degrees ends up being at -2. So you kind of get your tangent graph that looks like that.
So let's look at this next graph. So we have tangent of 2 and then parentheses theta minus 45 degrees. So negative 45 degrees is going to be my starting point. So that's going to be my middle. And remember that with tangent, we move the middle and go 2 left and 2 right. So 45 degrees is going to be my middle point, and I have tick marks here, so it's kind of giving you a little spoiler, but here is going to be my middle point at 45 degrees. Well, how do I know my quarter points? Well, my quarter points is going to be dependent on my b value, and remember that the original period length for tangent and cotangent is 180 degrees. So we're going to figure out that our period length is going to be 180 degrees divided by 2, so 90. That means my increment still for every graph is we're going to divide them into quarters. So we're going to divide 90 by 4 and get 22.5 degrees. So that means that I'm going to go 2 to the left, so subtract 22.5 degrees, which ends up being 22.5 degrees and 0. Then I go 2 to the right, so 67.5 and 90, which makes sense because that was our period length from 0 to 90. So at our ends, we have asymptotes. Okay, I'm going to just draw my arrows at the top of the asymptotes because I'm weird and I like to make sure my asymptotes are always going like that. And then we have our graph for tangent, which starts in the middle. Our amplitude for this was still just 1, so this is 1 and -1. And the regular tangent graph goes right 1 and up 1, and then left 1 and down 1. And you end up getting a graph that looks something like this. It would go the other direction if we were doing negative tangent. So for this next one, we have cotangent of theta minus 45 degrees. So this is telling us that we're moving our graph to the right 45 degrees. And remember that with cotangent, we're moving our first asymptote. So that means that my first asymptote is going to start here at 45 degrees. And this is where my asymptote is. Well, we don't have a value of b, so we're not changing what b is. So our period length is going to be 90, and our quarter points are going to be my period length is going to be 180 degrees because of cotangent, and we're going to divide those by 4 to get our quarter points, so 45 degrees. So each of my tick marks is going to be adding 45 degrees, and cotangent is different than tangent. We start at the asymptote and go to the right. So we're just going to go to the right 45 degrees for each tick mark. So 90, 135, 180, and then 225, which you can check to make sure that, oh, well, if you're starting at 45, one period length is 180 degrees. So we add 180 degrees to 45, and you end up getting 225, which is the end of my tick marks. Then we graph our cotangent graph, which the amplitude for this is just 1, or the points are 1 and -1, just like the parent function. And then cotangent and tangent both start in the middle. So, the middle tick mark in the middle, there's your point. Tangent usually goes right 1 and up 1, but cotangent is the opposite. So we're going to go down here and up here, and then our cotangent graph looks something like this. And remember that this is only one period length. Tangent and cotangent go on forever.
This graph doesn't move left or right, so I'm just going to leave it. You might have some in the assignment, so make sure that you ask in class before the quiz. So let's look at this. So this one here is our vertical shift. So that means I messed up my tick marks here, but I'm actually going to move this graph up 1. So my middle is actually going to be here. So then this 2 in front of the tangent is kind of my vertical stretch. So if my middle here is at 1, then my vertical stretch is going to go by 2. So we're going to go high of this point here at 3. We're going to go 2 from our middle and go down to -1. Okay, so again, this stretch here is happening vertically. So our normal point for tangent is that it would be 1 away from the middle, but in this case we're stretching it by 2, so it goes up 2 and down 2 from the middle, almost like amplitude. All right, so we did our vertical shift, our amplitude. What about this 1/2? Well, again, you're going to take 180 degrees, because we're talking about tangent, and dividing it by 1/2. Well, instead of dividing by 1/2, we multiply by 2 and get that our normal period length, or our period length for this graph, would actually be 360. And if I divide that by 4, we end up getting 90. Now, unlike every other graph where we always kind of start one place and go 4 to the right, with tangent, we start in the middle and go 2 right and 2 left, always. And I spread those out a little bit just to kind of show you how different that looks compared to our parent function. All right, so again, for tangent and cotangent, our ends are always asymptotes. So as long as you went 2 left and 2 right, then you should be good. For cotangent, again, you go to the right. So tangent, this middle, didn't get moved left or right at all, but it did get moved up. So our origin point went from 0, 0 up to 0, 1. Then the point over here would end up being at 3. However, we're reflecting it. So we're actually going to go down here, and the same thing for this point here. It would have been down here at -1, but we reflect it. So my graph ends up looking like this, which is a horizontal stretch since we divided it by 1/2, just to kind of show you what it looks like compared to our parent function. Okay. So again, with tangent, we move the middle, and then we have our quarter points, 2 of them to the right, 2 of them to the left.